Students, please find the virtual lab specific heat of metals using calorimetry or using a calorimeter lab. Should be in your packet. Actually, rather no, I am sorry, it is not in your packet. You're going to have to open this one up on Cami. And you're welcome to do the workflow in your packet where you've got room. You're really only going to need this data table and the workspace below. So it is possible to get away with just doing it in your packet. Go ahead and get it open on your Chromebook though, so you have it kind of in front of your face, ready to go. All right, and you can find everything you'll need for this lab, the virtual lab, right on our daily slide. Let me open that up so you can take a look at it. And that would be on this slide right here, where it says the virtual lab and the link for the virtual lab. So go to the daily slide, find this particular slide, and click on the virtual lab plus the link. I'd recommend opening up in Cami or getting yourself plenty of space to use in your packet to work out the math. Okay, once you click on the link for the virtual lab, I'm going to do that now, model what you guys need to do. It's going to be a simulator of a really good calorimeter. Go ahead and click on experiment. Go ahead and click on run experiment. Then you're going to select substances. Okay, so here's what the calorimeter looks like. And then the substance is going to be measured out here that you're going to try to figure out. So you're trying to figure out an unknown substance. Today you'll click on solid and you'll either be doing unknown metal number 1 or unknown metal number 2. Let's go ahead and start with unknown metal number 1. Drag the mass up to about 50. It doesn't really matter what your mass is. You can make it really small. You can make it up to 50 grams. I'll just randomly choose 50 grams. Temperature, you can heat it up 150. 150 does not matter as long as it's hot. You can go ahead and click next. And then you want to click over here, liquids, choose a liquid. You can use ethanol if you want, but you know what? I don't know the specific heat capacity of ethanol. So if you did use that, you're then going to have to click show the specific heat value. That one's 2.46. So I'm going to go back and choose water because I have that one memorized. Let's just max out the water and the temperature. You're going to go ahead and click next. And then click show graph, show macroscopic view, and then you can go ahead and run the first trial. Now, before you do run the first trial, you're going to want to take note of the following parameters on your lab document. So that would include, let me get it open on Cami here. Give me one sec. Okay, I'll scroll down. You can go ahead and skip over the directions. I already kind of showed you the directions. Go ahead and go down to the data table for unknown metal 1. So you'll put the mass of the metal here, the mass of the water here, the initial temperature of the metal, the initial temperature of the cool water, and then what the final temperature of both is, and then the temperature change of both. So essentially, you can work out the specific heat capacity of the metal to help you identify what that substance is, just similar to talking about calorimetry from yesterday. Okay, well, let's get back to our trial. So we've got the following things, 50 grams, 200 Celsius. I'm going to go ahead and record that with you all. We'll do one trial together. Mass of the metal is 50.0 grams. The mass of the water, what did I do? I did 200 grams of the water. The initial temperature of the metal, I think I heated it up to 200 Celsius, 200.0 Celsius. Initial temperature of the cool water, that's going to be 20 Celsius, basically room temperature. All right, final temperature of both, we got to wait. Okay, let's go ahead and click start. Run the little experiment. This is an idea of what a real calorimeter would be doing. Close it. Now measure the temperature change. Notice the hot metal has atoms that are moving rapidly back and forth, and it's going to transfer that energy through collisions to the water surrounding particles. Now the water is going to start to move faster and faster and faster as it heats up, and the metal is going to start to move slower and cool down. Notice they don't change temperature the same amount. Isn't that curious? Well, that's because the heat capacity values are different. All right, final temperature is 24.08 Celsius for both. 24.08 Celsius for both. Okay, now we do the temperature change of the water. So the water is going from 20 to 24.08. That's a positive 4.08 Celsius increase. And the metal is going from 200 down to 24.08. So 24.08 minus 200 puppies is negative 175.92. Wow, look at that temperature drop. Dang. Okay, cool. All right, now we can show the work to get the specific heat of the metal. You need to remember that Q of the metal is equal to the Q of the water. You can set up M equals C equals delta T equals, and M equals C equals, and delta T equals on the metal side and the water side. Keep in mind you have to multiply MC and delta T to get the amount of energy the water absorbed. That will be equal to this, but opposite in sign. Finally, you'll have to do some division to calculate your C value, and then you can take a peek at the data table in our slide deck and note that we've got aluminum all the way down to titanium and the resulting specific heat capacity values to help you identify that unknown metal. All right, repeat that 3 times for both unknown metal 1, and then try it again for unknown metal 2 and see how close you can get. And then next week, we'll go ahead and run the real simulation or the real lab. All right, hope this helped. Good luck on your calorimetry experiment.